Let's take a look at this true or false question. In 223, there will be a lot of true or false questions appearing on the midterm or the exam. So it is very important and essential for students to know how to prove or disprove a statement. So in general, to prove a statement that is true, so if I want to prove that something is true, then I'll have to state the relevant theorem, proposition, or the facts given on the question to prove that it is actually true. So notice that you can't just give me one example. So if I'm proving something that is true, you can't just give one example for that. However, if I'm proving something that is false, then only one counterexample will suffice. All right, so now let's take a look at part A. Part A, it is a if and then question. So if a consistent system has 6 variables and 3 equations, so variables, we can identify them as unknowns, or in the letter, we can say this is n. For equations, it's the number of rows, so this is m, because we always have an m by n system. Right? Then it's saying that the solution must have 3 parameters. Now, because this part is talking about parameters, why don't we just write out the formula for finding the number of parameters? So the number of parameters is found by using n minus r. So n is the number of variables, r is rank. Okay? And as I mentioned in the weekly recap, there is actually a very important relationship between rank and rows or equations, or simply the letter m. And the relationship between m and r is that r is always less than or equal to m, simply because r is being obtained in REF, right? However, m, it's always there when you're given that matrix. So you'll have to go through a series of row reduction. So that's why r is always less than m. So now, the question is saying that if a consistent system has 3 equations, 6 variables, then it must have 3 parameters. So since r is less than or equal to m, so the number of parameters here has to equal to 6, because n equals to 6 here, minus r. So r could be 1, 2, or 3, because r has to be less than m, and m equals to 3. So this part A, this statement, would have been true if we know that r is exactly equal to 3. However, since r can also take on the value of 1 or 2, in this case, if r equals to 1, then the number of parameters here equals to 6 minus 1 equals to 5, which contradicts with the statement here. Then the solution must have 3 parameters. The fact that the statement used the word must means that 3 parameters is the only solution. But in fact, no, because we do have a counterexample here saying that if r equals to 1, and because r can be taking on the value of 1, 2, and 3, if r equals to 1, then our number of parameters here will actually be equal to 5, which is not equal to 3. So this is a counterexample, hence this is false. I'll be explaining part B in the next video, and please don't forget to check it out.